In this section, we will go over specific rules when dealing with vectors and their computations. Rule number 1, commutative property of addition. It just states that the order of adding the numbers does not impact the result. For example, if you were to add two magnitudes, one of them having a value of 3, other 2, your result would be 5. But you can also change their places and add them in order 2 plus 3, and you'll get the same result. This also can be applied to equations like this, where you can change the order, or when adding vectors. Rule 2, associative property of addition. This states that you're free to associate the number however you choose. For example, if you have numbers 3, 5, and 8, you can associate them in this way by separating into brackets. You can also apply this to equations such as this one, and your result will be the same, or when adding vectors. So it just doesn't matter what you separate the brackets into. Rule number 3, distributive property of addition. This rule states that you can factor out a common value and distribute it into brackets, and your result will be the same. Such as in this equation, distributing the value will not impact my result, or when I distribute the value k into my vectors, I will get the same result. Now, in this question, they want us to simplify the following expression. First, from the properties I saw, I can start with the distributive property and distribute this 3 to the bracket, as well as distributing this negative to the brackets. Now that I have it, I can regroup the A's together and regroup the B's as well as the C's together by the commutative property. So what I mean by that, I'll write 6A and I'll put this negative A right next to A. Now I'm going to put 3B. Now I'm going to get this negative 3B and put it right next to it. Now I'm going to have that 3C and then put this 2C. So this reorganization is going to be the commutative property. Next, what I can use is, if you want to just do an extra step, distributive property for scalars. So what I'm going to do is I'm going to take out the scalars from that A to get a value of 6 minus 1. So I took that A vector out, and I'm going to do the same thing for the other one. So I'm going to put it into brackets. So basically I'm taking B out, and I'll be taking C out of this as well. Now from here, all I'm going to have is 5A, and that's 0. So you can put the 0 vector or just leave it alone, and then plus 5C. And as a result, my last answer is just 5A plus 5C. So that's it. So there are also further laws of vector addition and multiplication we need to consider. One of them is when I add the 0 vector, it is just as adding a 0 to any value. I will get the same vector, which is a vector A in this case. Second one is associative law of scalars. When I have a scalar value of m and n, and my vector is A, it doesn't matter if I put the scalar n inside the brackets or m, I would get the same result. Last law is the distributive law for scalars. If I have two scalars where I add them together, I can actually distribute the vector this time to get the value of ma plus na, so it's just distributing the vector inside. Now that I know all the properties that I need to know, I can just start with this question. The rest of the questions on the textbooks are more like, if this is the x equation and this is the y equation, just do x plus y, which is very similar to the way we did it in terms of the simplifying question. So I will not be solving those, as they're more of like easy problems that you can do on your own. And I want to solve this problem, and this is more of the different type that I saw on the textbook. So if 2x plus 3y equals a, and negative x plus 5y equals 6b, express x and y in terms of a and b. Now, because this contains 3 different variables, I can do, I need to eliminate one of them. So what I can do is write down 2x plus 3y equaling to a, and then write negative x right underneath plus 5y equaling to 6b. And these are all vectors. And I just need to cancel one of them. What I can do to cancel, the easiest way is I can multiply this equation by 2 so that I have 2x plus 3y equaling to a. So underneath I have negative 2x plus 10y equaling to 12b. Now I see I can actually cancel these two out and have only one variable on the left side, so I can solve for y. So now I have 13y equaling to 12b plus a. Remember, these are not the same values. We need to write it in terms of a and b, so we're good. Now all I need to do is divide each side by 13, so I find my y in terms of a and b. What I'm going to do is I'm going to put this a to the front just to make it easier, makes it look nicer. So I'm just going to say 1 over 13a plus 12 over 13b. And that is my y value. That's my answer for y. But it also says express x. So what I can do is I can plug this y back into, let's say, this equation. You can choose the other one too, but because it looks easier, I'm just going to choose that. So from there, what I'm going to do is I'll put negative x plus 5, but in the y component, I'm going to replace it with what I found. So 1 over 13a plus 12 over 13b. And this will still be equal to 6b. Now from here, I'm going to distribute that 5 into the brackets. So I have negative x plus 5 over 13a plus 60 over 13b, and that equals 6b. Now, because I'm trying to isolate x, I'm going to send these two as negatives to the other side. I realize I can actually rewrite 6b in terms of the denominator given over here to me, so I can add them together. And when I do that, I get a value of 78 over 13b, which corresponds to what 6b is. Now I'm going to send that 60 over 13 to the other side as negative, so I have negative 60 over 13b, and I have negative 5 over 13a. Now from here, I see that I can actually add these together, right? And I would get the value of 18 over 13b, negative 5 over 13a. Now all I need to do is get rid of this negative by dividing each side by a negative, so by negative 1. So that would give me a value of negative 18 over 13b and plus 5 over 13a. And if you want consistency between these two, you can just switch the places too, but that's your answer because I ran out of space, so I'll just keep it as that. If you have any questions concerning this video or any other problems concerning MCV4U, the calculus course as a whole, you can always go to our website and go to the forum section where you can post problems which we will send solutions to.